Good morning. So this talk is titled Music Research in the Big Data Era that explores the exciting intersection of music and the vast realm of big data. The discussion promises to unravel the innovative ways in which data analytics and technology are reshaping the landscape of music research. Our keynote speaker, Dr. Vinoo Alluri, earned her PhD in musicology from the University of Jyväskylä, Finland. Subsequently, she undertook her postdoc at both the Department of Music at the University of Jyväskylä, Finland, and the Neuroscience of Emotions and Affective Dynamics Lab at the University of Geneva. Presently, she serves as an assistant professor at IIIT Hyderabad. Her research spans diverse disciplines encompassing music cognition, neuroscience, music information retrieval, and cross-cultural studies. Whether you are a seasoned researcher, an avid enthusiast, or simply curious about the evolving dynamics of music in the digital age, this talk is designed to be an engaging journey into the fascinating world where music meets the big data. So without further ado, let's delve into the captivating realm of music research in the big data era. Please, ma'am.
So hello, everybody. You can hear me fine behind, right? Yes? Okay. So she said it's very captivating, it's this and that. So a lot of promises have been made. So I'll try to, make it entertaining at least. Okay, so I just realized, I think in the morning when I was watching, the first presentation, that what I'm presenting has nothing to do with speech and audio processing, right? And I feel like I should have picked another topic, but I suggested, they said yes. But when we think about the main theme, which is AI for music, I think it sort of fits the bill, right? So, okay, so before getting into all of this, a little bit of background. I did a lot more work in neuroscience, and that's where my signal processing, and also I did a lot of acoustic acoustic signal processing and feature extraction in my master's and my PhD. So there's all of that. But then I slowly started to move more towards understanding the human musical experience, looking at music cognition, trying to get the human element in, because at the end of the day, I used to think that, okay, if I look at a signal, I look at brain signals, this is it, this is what is happening. But then I realized that without actual understanding and verbalizing of what's happening, just looking at a signal might not suffice, right? So from then on, I started moving towards music cognition and all of that a little more than before. Okay, so just a couple of slides. I have 3 slides on what we do at IIIT. So finally, after a few years of joining IIIT, I have at least a bunch of students. We call ourselves a music cognition group, because when I first joined, people didn't know anything about music research, right? So we do a lot of different kinds of things, and all things related to music. So if I just zoom in a little, you see that roughly, I would say 20 students. And then we, because this work, as was mentioned, that MIR is interdisciplinary, and when we think about combining MIR with fundamentals of music cognition, neuroscience, and so on, it becomes even more broad. So I do have a lot of collaborations with in India and abroad. And then we do have some funded projects, and my main, it's the first 2 projects that I will be talking about today. So it's about trying to use social media and music consumption patterns to understand the human musical experience, especially in terms of mental well-being, and also what has been happening during the pandemic. So yeah, so if you can see that we have all these areas, so movement-related research that we are trying to look at, trying to predict something about the individual in terms of what the movement patterns talk about when they move to music, right? What can they reveal? We have soundtrack generation for books, where we're trying to use AI to generate soundtracks, and how can we sort of use that, let's say, for audiobooks. We have cross-cultural studies. We are looking at, of course, neuroscience has taken a slight backseat, I must say, but then we are also trying to move towards interpretable AI. So we're trying to understand how, these large, let's say, audio models, how they're encoding music, how can we sort of interpret what's happening there and maybe derive from neuroscience to make sense of that. But today's talk will focus on the other three aspects. So one is about analyzing social media, analyzing online discourse, and looking a lot into lyrics, because in the field of MIR, I would say that lyrics has not been as investigated as acoustic signals itself. So, and that's a very, I would say, recent development, maybe less than a decade for sure. So we have a very strong linguistic, computational linguistics group at IIIT. So we work with them as well. And then, of course, all of this, how we can use it in the context of health and well-being. Okay, so starting with the talk, the main part. Now, we know that technology, right, has been shaping our musical experiences drastically. So just the availability of music through our mobile phones, wherever we go, there's music everywhere. You can't seem to escape it. And that's sort of also changing what music probably even means to us, right? From an evolutionary perspective, music, one of the main functions it served was to sort of bring people together. Because if you play music together, you're sort of sharing affective states. There is maybe there's a ritual happening. So there is some sort of bonding that is actually quite crucial for survival, right? So when people talk about any survival value that music has, then that used to be one of the main reasons. But nowadays, everything has become very personal, right? So you are listening to music just through your headphones most of the times. So it's also, then that begs the question, okay, what role is music actually playing for us as a society, right? And what does it mean for future research, and what research questions should we be asking? So during COVID, there was this exponential rise in Spotify users across the world, right? And Spotify had just started, I think in 2019, that's when it came to India. And all over it saw a huge rise in Spotify users, right? And of course, other streaming platforms as well. And then people were sharing a lot of these things on social media, on Twitter, wherever people were posting music just to feel better, to overcome, to maybe feel one with the people all over the world during times of distress. So it's really, that's what sort of has given rise to this whole movement of making music center to our lives. Not that it wasn't that central to our lives, but this sort of continues. And this is what I'm talking about in terms of big music data, right? Because you're consuming music, you're sharing music, and that seems to become a very crucial part of your identity now. So which means that also probably says something about you, right? Very interesting questions we can ask. So just to talk about the term big data itself, right, can be characterized by 3 V's: volume, variety, and velocity. So volume, it's evident. So that's massive amounts of data which is generated from various sources: social media, sensors, online music listening platforms, and more. And variety stands for the diverse kinds of data that is being shared via these platforms and is accessible to us as researchers to analyze. For example, you could have very structured data. So you have these traditional databases. So people are just making data available. So they might extract some features or just make it available, conduct hackathons, and so on and so forth. So Kaggle is one very good, place where all of these data sets are freely available, right? So they're very structured. You also have semi-structured data like XML, JSON, file types. And this is something which, let's say, as a Spotify listener, I request for my music listening history. They will send it to me, and it will be in the form of JSON files, sort of semi-structured. So they send me time-stamped information about what I was listening to, when I was listening to, and so on, right? You also have unstructured data. That's what you see in social media posts, right? People just post random things. They can be sentences, half sentences, bullet points, tags, all of that. And that comes with text, with images and videos. So you can now sort of use all these existing tools to somehow make more sense out of all of those. And those are the studies that I will talk about in a bit. And then velocity, of course, that, how much we are consuming and how much data is being generated every minute, right? So it's huge amounts of data. And this is a great time, as long as all these APIs or application program interfaces are working and we can extract data, it's great. Twitter shut down its thing, so we can't do Twitter-based analysis. But otherwise, we are able to work with other platforms and get so much information. And it's really, really rich. Of course, it has its own drawbacks, which I'll cover a bit later. But I think it's a great time to be looking into all of this to understand human musical experience. And of course, because of because of all of these V's, let's say, that for big data, we do require advanced tools, technologies, and algorithms to extract, store, process, visualize, and analyze all this data so that we can uncover patterns, trends, correlations, and insights that were previously difficult to obtain at large scale. So if you think about it, people have been doing music cognition research has been mostly restricted to lab settings, right? And now this is a great time that it allows us to sort of extrapolate all of that and investigate that in a much larger setting, and hopefully in a more slightly ecologically valid approach, because you don't have the lab-based constraints, right? So we'll look at that also in a bit. So, but what questions can you ask? So each platform, right? So we have Reddit, Twitter, Last.fm, Spotify. So those who don't know, which are very few here, but Reddit, who doesn't know any of these icons and platforms? And that's a better thing. I guess. So, so which one? Twitter. Unfortunately, yes, you know that. Okay. Sorry? That is actually Last.fm. Last.fm. It's not available in India. But this streaming platform, I think 2008, I remember using it, but I was in Finland. It's available in Europe and other countries, but not here. So, and Spotify, we know. So Twitter, these, right? These streaming platforms. Now this is becoming a lecture of sorts. Yes. Yes. Okay. So Reddit is a place where people anonymously, they can share, discuss anything they want. You have focus group. So you have, let's say I want to talk about music, there will be a music channel or a music group, and I can post comments, questions, people interact there like that. So, and it's anonymous, so people can freely post things, unlike Twitter, where you have to look a certain way. There's social desirability. You want to appear a certain way. So, that the kind of discourse that happens on Twitter is different from what would happen on Reddit. So Reddit is a bit more honest, I would say. Okay. So each platform can address different questions, and you might have to rephrase questions accordingly, or maybe each platform can address some part of the question, right? So let's say that I want to look at something which is about social aspects of music, something in the public eye, then I might look at Twitter and Reddit. But if I want to look at something which is more personal and private, then I would have to look at what I'm actually consuming, right? Because all these recommendation systems are so personalized now that they have to look at your own history and then say, okay, this is what you're listening to. I think you like A, B, C, D, right? So it's becoming very personalized. But there are places, again, within these social public platforms, Reddit is anonymous. So let's say that I want to look at, I want to understand, okay, I want to design, let's say, recommend music, well-being, depression, all of that. I want to suggest music which maybe helps them feel better. Then what would I do? I could just go and look at what people actually share, saying that this is what makes me feel better, this kind of music, because it gives me these kinds of rewards. I could look at Reddit and Twitter, but then depression is something, or well-being is not, there is some stigma attached to it. So people might not be as honest on or open to things on Twitter. So I might want to go look at what people describe in terms of depression and music and what it does on Reddit, right? And the good thing is that these two platforms, they happily post links to Spotify tracks. They say, oh, this is a song. Listen to this. This will make you feel like this or make you feel better. So that way you can connect all of that and try to get a more comprehensive understanding. So I want to give one question. Let's just take one example, right? So where you're starting from what was done previously in lab settings, and then how you can sort of extrapolate that to the current scenario now. Let's take one study. So one study that was done in the lab, when I say lab, well, it was surveys, of course, interviews and self-reported surveys, but still in constrained settings. So unhealthy music listening strategies are associated with depression risk. I will get into that because you need to understand what that means. So this was something that has been observed, that music is not always a great thing, because if you don't consume things properly, like junk food or any food for that matter, too much of a good thing might not be good for you, right? And what sort of patterns, in which ways you consume things also can have undesirable effects sometimes. So let's just get into that study, which was done in a lab, right? and then how we can use all of this to unravel more things about that particular finding. Okay, so this study was performed on Australian adolescents, right? Adolescents, young adults. Because when you think about depression and well-being, you have to try and intervene or identify at an early stage so that you have more effective techniques for overcoming all of that. So this study was one where they identified what is called a healthy, unhealthy music scale. Okay, basically it's a 13-item questionnaire. That's all it is. And it's an instrument to detect a risk for depression and potentially other mental health problems in a non-intrusive way. What does that mean? That if I directly give you a depression-related questionnaire, maybe people are a bit hesitant to answer certain questions, right? Let's say, how suicidal have you felt in the past 4 weeks? People might not want to, say yes, no, maybe, whatever, right? So through your music listening habits, it's an indirect way to actually identify. So let's get into, let me show you what that is. So it's a 13-item questionnaire. 8 of them are what we call as unhealthy, and 5 are healthy. So it gives you a healthy score and unhealthy score. So what I mean by healthy and unhealthy here, right? So let me give an example. So if one of the items which is considered as healthy is music helps me relax, well, that's good, right? And if I agree to that, then that's a good strategy. You're using music to make yourself feel better. Or if I say I feel happier after playing or listening to music, music helps me connect with other people who are like me. All these are beneficial for you, right? When you consume music, these are the outcomes, that's good. But what about the unhealthy items, right? So if you agree to something like this, I hide in my music because nobody understands me and it blocks people out, which means you are using music to avoid something. It's like an avoidant coping mechanism of sorts. And then if you say, I like to listen to songs over and over, even though it makes me feel worse, right? And people actually do that, by the way. If I hope none of you are doing that, but it's highly likely that it's not highly likely, but they've observed that this sort of ruminative behavior is also not beneficial in the long run, especially. And if another unhealthy item is, it can be hard to stop listening to music that connects me to bad memories, right? So basically, you are using music, you might use music to relax also, but if you use music in such ways, then that might not be beneficial, and there is something going on underneath all of this, right? So in one sense, avoidance mechanisms or ruminative mechanisms, right, might not lead to positive outcomes. So these are unhealthy items. So what this study found, the higher the unhealthy score, the higher your psychological distress levels, right? This is a standard questionnaire, psychological distress scale that they ask in clinical settings. So higher your unhealthy scores, higher your distress, and lower your mental well-being, right? So in one way, it's sort of an indirect way of identifying this. Now, so that was the lab-based study. So what do I do now? What can I check? Well, first of all, you have to check that was on Australian adolescents and young adults. So number one, if you're going to do any research, you want to situate that as well. So we did that in India. Same, you get almost identical results, right? Different age groups. Even with our beloved IT groups, same patterns we see, right? So one is to check the validity. But then that's fine. You're still asking them in a very constrained setting. But what about in more naturalistic setting where people just talk about all these things, right? So this is where you can look at Reddit, and there's a subreddit or a channel as in a way. It's called r/depression. It's the biggest group with several thousands to hundreds of thousands of subscribers to that. And there's a lot of discourse on depression, right? But what you can do is you can filter out depression and music-related discussion. And then you can use all your language modeling to actually make sense of that. Twitter, of course, Twitter doesn't work. You can't really use it for something like depression. And of course, now we don't have access to all that data, so we can forget about that. But then what is interesting is, so far, I've only been talking about listening strategies. I'm not talking about what kinds of music, what am I actually consuming, right? In order to do that, I should dig up your listening history, right? I need to see, okay, 6 months, 4 months, 1 year, what have I been listening to? So that's where you can use data from Spotify and Last.fm, Now, Last.fm, it was easy if you have the any Last.fm users user handle, you can get their data. Spotify doesn't allow that. But of course, what we did was we asked people, we paid people to give their Spotify listening. So request and give us just that. So that's one way of getting that information. And then we can also ask people to, fill in these distress questionnaires and all of that. So we have some idea about their mental states. And then after that, what can you do after that? Well, you can change the question now and say, how does one feel while listening to music maladaptively? So starting from a lab-based study, you can take it to online discourse to understand what music and depression, what do people really talk about, what kind of music they consume, which makes them feel so bad. And then also the next thing is, now that we have all these wearable technology and you have these apps that allow you to sample your experiences as you go on in your everyday life. This is an app called MuSic. So it's usually used in music research, and it can track certain, let's say, moods. It can track what you're listening to over a few weeks, depends on how long you use the app, so that then you understand what is actually happening in your body as well with all the sensors that you can. So that way, at least you get a more holistic idea of, musical experiences. Okay, I will delve into the studies a bit more, but first, so when we think about these 4 platforms, you have all the respective APIs. That's just the logos of each of the respective platforms, which allows you to extract all the information. Now, once you do that, what do you do with that information? How can you characterize that kind of data, right? So let's start with streaming platforms. So music, so when we think about Spotify or Last.fm, what it essentially gives you, like I said, is semi-structured, time-stamped information about your music consumption, right? So what you see in the middle is what we call a stream graph, but it just assume that each color is one artist, and on the x-axis is time. So it sort of tells you, okay, at a particular time, I've been listening to more of Green Day, or I've been listening to more of Blur, or, so you at least have some idea of what kinds of music you're listening to. Now, you can look at several aspects of this. One, you can look at usage statistics that, okay, I listen to music maybe once in a week, or, maybe 5 hours a day, something a bit more general and broad. You can also look at acoustic features. You can extract, the features from that. You can look at tags. When I say tags, not all platforms give you that information. But let's say that something like Last.fm, it gives you user-given tags, meaning that if I have a song, you have several tags. So this is wonderful, awesome, rock. It can be anything, right? All kinds of tags can be available for that. And then you can look at lyrics. Again, that is something vastly neglected in MIR, but now it's becoming, more and more important. You can look at artist information and so on, right? So there are many ways. So let's just look at some of these in detail. So from usage statistics, right? I can look at it from a static point of view or a dynamic point of view, right? Meaning that I can look at your, let's say, total play count. I want to, let's say, understand 4 months, how have you been consuming music? I can look at the total play count. I can look at how many, have you been repeating music too many times? Or how much do you explore, right? Are you a very open person that likes to explore all kinds of artists? So this is not an exhaustive feature list, but this is just that you get an idea. So I can get some sort of an overview of, your music listening patterns. But I can also divide them into, sessions, or I can decide what the temporal resolution is. Do I look at your consumption weekly, daily, or session-wise? And what constitutes a session? Now that is also up to discussion. Let's say that I'm listening to music for half an hour, right? I'm doing my work half an hour. And then after that, there's a 2-hour break. I've gone somewhere, and then you return to listening again. So maybe giving a break of 2 hours might be one way of defining sessions, right? But there are different ways that you can do it. So basically, you can divide your listening history into some sort of, use whatever temporal resolution that you might need. But of course, you have to justify that. And then you can look at the inertia and variability of these features session-wise also, right? So you want to understand that do I always listen to a certain kind of music? Is there a lot of fluctuation? You can even extract other features such as, let's say in one session, I'm only listening to party music, right? And then there is, let's say, a lot of in terms of lyrics, right? It's just lyrics, very repetitive. You can imagine pop music, party music, dance music, it's very repetitive. So maybe, you can look at how that changes over time. So lyrical features also you can extract and then see how it changes over time. So basically what you get is an overall descriptive measure of your listening, your usage statistics, or you can look at time series of those as well, right? And this time series sort of, for the other features that we can extract, tags and everything else, you can look at the time series for all of those as well, okay? Now, acoustic features, you will learn feature extraction as part of this winter school. But unfortunately, when you're dealing with such huge amounts of data, it's not feasible, really. Well, first of all, you can't download all the music, right? You can't, how do you do that? And how do you do that without any legal implications? And then you have to extract all these features. That's not feasible. But Spotify has given a list of features. And this is something that I find that of late it has been overused. Even in ISMIR, you find papers and just all over as well, where if one wants to extract features from music, no one is using signal processing techniques, unfortunately. And they just go and say, oh, we use the Spotify API, we got all these features, and this is it. But this is not enough to represent, music. This is a very small list. But of course, you could make do with this, but there are certain other issues that we have also observed, that when we think about these features in terms of their perceptual validity, right? Let's say that I talk about something like valence. How happy is the track, right? Don't worry about the BPM part. I think that's a mistake. Valence is about, when you think about sentiment, positive, negative, pleasant, unpleasant. So valence is signifying that. So it can be a subjective, feature, right? So valence, and that too for, let's say, Telugu music versus Hindi music versus music, Tamil, all of that. There could be these variations and people might not agree, but Spotify still has it's like a black box for us. We don't know how they've obtained all these features, and they don't describe that anywhere. So we did see some discrepancies in terms of valence and other features as well. That is why it's important to situate music research, because all of this has been done on predominantly music with lyrics in English, right? So it's very, very important that we do more work on extracting features which might be relevant also in a more, sort of cross-cultural context. Okay, so back to this, you have a bunch of features, 11 features or so, everyone seems to be using it. It's not that representative at times. You can also sort of use valence and energy because and to come up with emotion related features, because one of the very predominant models we use in music emotion research is the valence and arousal of valence and energy two-dimensional model. So valence is on one axis and you have arousal on the perpendicular axis. So basically what it says is if something is very pleasant and high in energy, that is a quadrant which is representative of joy and happiness. If it's negative in valence and maybe low in energy, then that's representative of sadness. So this is a two-dimensional valence arousal or valence energy emotion model commonly used. So I can use both these to maybe project them into that space. So at least I'm getting something a bit extra other than just valence and energy. Valence and energy as in the music itself. Music itself. Yeah. So what I can, yeah. I can show them in there's a classification task, MIR classification tasks, and I thought genre and emotion could be one of those. So maybe during this school, if that's okay, Wednesday morning, I can cover that there. Yeah. So, yes. Yeah.
And all upbeat musics have like very high values for balance and energy.
Not necessarily, no. They don't have to have high energy, yes. You would expect. Valence, not necessarily.
And also danceability, because any upbeat music.
See, this is the problem. This is the problem with these features, because yes, you're right that, they could be danceable, but again, see, you're extracting all of this from a signal. And whether it's perceptually relevant or not is another question altogether, right? That is what we try to solve in music cognition research. So again, your question was, did I answer?
Oh, yeah.
Okay, all right. Sure. Yeah.
Assuming here that every listener is an independent source of data.
Yeah,
Big
yeah.
data,
Mhm.
big listener, and a lot of context.
Mm.
So independence, like in what we have done in statistics and probability, that is what is being assumed. But physically, they are not independent. They are part of a society.
Yes.
So they have learned to do
Mhm.
that.
Yes.
In fact, in most of what you said, probably there is no shadow of Indian culture, Indian business, etc. Maybe a small percentage of the generation maybe picking up. But most of the data would be Western European, or Finnish. In
Yes.
fact, Finnish habits cannot be compared with German habits. German habits cannot be compared with the jazz music of US and all that.
Yeah.
So there is a very strong social aspect. So I think these parameters will make sense in the context of some. So it's like almost like linguistic research.
That exactly. So
Yeah.
I completely agree. Yeah.
Telugu vocabulary, Telugu speakers, Telugu meaning. So it's Telugu. That's it.
Yes. Yeah, in fact, yeah, that was why I was saying that these features cannot capture something which is culturally learned sometimes, especially something as valence and energy. I can imagine danceability, that's a bit more objective in one sense, but still, what is danceable? So these features are problematic to some extent in their meanings and associations. Nevertheless, they're still being used for large scale data. In fact, this would be great if you can find a way to extract features from music using, I mean, if people describe music being a certain way, then can we actually... Genre, I'm coming to genre. Genre is a very fuzzy concept. Yeah, it's very fuzzy. I have slides on. Of course, yeah. Everything is fuzzy now, looks like. Okay. So, all right. So this is just a list of features that is... Yes.
Yeah, just to follow up. So, when you talk about valence and energy in comparison to the valence arousal, which is usually, I guess, collected like self-reports and stuff like that, but like Spotify is probably doing something like we don't know what it's doing, right?
Yeah.
So, like this valence energy, like has it been like validated, like with other MIR study, like other music emotion studies of valence arousal?
See, this I don't know whether Spotify did that, but there are studies where, well, first of all, they take an annotated database. That's how you start, right? You have valence and energy annotations from several people, and then you train a model, and that's that, basically. And
what I'm saying is, like for this analysis, like you're using the Spotify features.
Yes, yeah.
But then if the Spotify features correlated with like if there are certain like music data sets which were used in the music emotion research, which are also available on Spotify. Like
Right.
that's not a validation.
Yeah, that what we did was we did a perceptual validation of features, of tracks. Just listen to them, rated valence energy, and correlated that with what this gives. So there are discrepancies, especially there are discrepancies, and especially they did it in a context of Indian music.
Yes.
So there is that. Yes.
My question is also a follow-up to Professor Srinivas' question about an example of representing these two parameters with respect to the emotions. So, something back you said about sentiment.
Yes.
And then you also said that there is some kind of fuzziness in the quantification of those levels with respect to. So one of our work, what we are doing is that we are taking the data set like Moody lyrics.
I know, I'm aware of that. Yes.
Yeah. So from that, for those sentences in the song, we try to find out whether the song is related to first person, second person, or third person in that.
Right.
And then the relationship amongst them and all. let's say one of the song memories where somebody is remembering about the love in the earlier time and remembering the ex. So in that the sadness is there. So these are the examples that I wanted to give. So my question was then that this balance and energy, are they also somehow related either explicitly or implicitly to represent us this sentiment, and then the sentiment is broken into, let's say, identity in the song, then settings in the song, and the sentiment. So, like, we are decomposing the piece of music into these three components. So, because rightly said, that sentiment alone is not at all, sufficient to represent the emotions in the music. So how the balance, energy, and the emotions are connected with this kind of decompositions of like setting, sentiment, and identity. Identity, I mean the human identity. Setting, I mean the tense, like past, present, and future. And the sentiment can be, as Professor said, the positive emotions and the negative, sadness and happiness. So how they interplay?
So one is that, of course, the sentiment itself is just positive, and unfortunately, it's reduced to positive and negative, especially in linguistics research, right? But in music research, especially music emotion research, first we make distinctions between perceived emotion and felt emotions. And then there are different kinds of emotions, basic emotions, more experiential emotions. There are several emotion models. In music cognition research, they're still trying to figure out what are music emotions, right? Because just happy, sad, they're very basic. That they don't suffice. So there are several different models still being proposed in terms of music and emotions. And then from acoustic features, we can only think of extracting perceived emotions, that it sounds happy. Do I feel happy? No, that is a completely different question altogether. Now, how that relates to context and identity, I mean, that's a completely different question. They're the question altogether, which I don't think, I don't know of research that has done that. I don't know. But of course, all of these are interrelated. That's why we want to contextualize things as well. So, yeah. But that also brings me to the point that lyrics is so crucial. Language and the role of language in the musical experience, which has been neglected for so many years.
Just to make an anchor, our work is following the Duslin's work with the music information system. Duslin's work in the music cognition and all.
Right. They did a lot of music emotion. Yes, indeed. Thank you. Yeah. Yes.
Therefore, different variety of this. So your listeners, that in your lab, that experiment that is made, I'm sure the Indian listeners.
Yes.
Their training, I mean, you're trying to validate their massive collection of Spotify with your listeners. So what I have learned as happy now, memory, melancholy, that is different. Something that I would have learned in my generation, even the generation to generation, there will be differences.
Absolutely. All of this varies. Yeah.
Very big problem.
Well, so many problems you can solve, so many PhDs you can produce with that. So why not? Yeah. Okay. All right. So now lyrics and tags, right? Now, because we're dealing with words, so enter NLP here, right? So now this is something, again, I'm not from that domain, but I'm just showing you a very, a higher level intuitive understanding of what is happening and what we are kind of taking from that, right? So all these language models, they're kind of converting words into representations of what they call embeddings, right? So numerical representations of words or sentences, paragraphs, whatever. But the idea is that you're converting that into an n-dimensional continuous vector space. You basically have, numbers, that each word is represented by a string of numbers. Now, let's say that that is the representation of king, man, they're all numbers, right? This is color-coded here. So just to understand, so king, man, and woman. Now, the goal of these word embeddings is also to capture the semantic and syntactic relationships between words, meaning that words that mean something similar will be closer in that particular n-dimensional latent semantic space. So if I were to take, let's say a king, the representation of king, subtract the representation of a man and add the representation of a woman, I should get something that approximates queen, right? So now if you look at that if I just subtract the first three, from the first row, I subtract the second, add the third, right? And this is what I get. And these two should be more similar to each other than the other ones, okay? So the idea that you can use NLP to sort of deal with tags and lyrics to create, again, you're basically using some sort of numerical representation, which makes it handy for us to process all this vast information and the semantic associations between them. And you can do this at a word level, sentence, paragraph, song level, right? You can do all of those. You have different models, which you can use. Now, what do we do with tags? So these are the tags for the song Stairway to Heaven by Led Zeppelin, right? So you see that the tags, mainly you have classic rock, 70s, hard rock, all of that, but you also have some other adjectives and adverbs that are representing something about the track, not just basic information about genres. So what we do, or what we can do, you can use a parts of speech approach to sort of extract the adjectives and adverbs, take their embeddings, right? And of course, you have you have like an already pre-trained word emotion induction model, which basically says that given a word, it sort of learns what the valence and arousal, location is in that space, right? So basically, it learns to associate with each word a valence arousal value. Now, if I take a word like, okay, let me just show you this animation. Okay, let's say that I take a word which is, if there's a word like awesome there, okay, then maybe if I use this model, it will project it into the valence arousal space and maybe somewhere here, okay? Now, that just tells me which quadrant it lies. It just gives me some valence and arousal values, but I want to understand what emotions it might be conveying, right? So then what I can do is I can take a music emotion model. Now, the emotion models are very different. General emotion models are different from music evoked emotion models. This is one such emotion model, 9 emotions. So what I can do is that I can take, let's say I've taken a word, music emotion sad, and I've used the same model to project it into the space. Then what it does is that I can now take my adjective adverb and I have the projection of one of the emotions. Then I can check the distance between those two projections to see how close or far away it is. So this way, I can assign each tag to one of the 9 emotions based on proximity, right? So that way each track has some emotion associated with it, right? So this is one way where you can use, project all the tags into music specific emotions. Of course, you can vary the emotion models. Like you said, valence arousal is just too broad and, you need something more specific. It's still going on. 2020, we had another model. There's one more model coming up. So it still goes on. You can, of course, pick whichever emotion model you wish, and then that way you have tags to emotions that you can extract.
These three are parameters we can relate to sentiment also.
Of course you can, because I think anything which is positive, maybe it's going from positive to negative, as you can see. So I would say something here you cut off and that becomes negative. So on the spectrum, at least. Yes, please.
The previous example was the NLP example, very beautiful. So I think we are academics, so we have some freedom to talk about.
Yeah.
You can say that it's algebra of semantics.
Sure. Why
So
not?
You can use
Yeah.
algebra of emotions maybe here. I don't know.
Algebra of emotions. Yeah, it doesn't seem like algebra of emotions, but yeah, yeah, but definitely, yeah.
It's important because it's only humans who have injected that intelligence into the system. Man means male, female, woman
Yes.
means female. So king has a male component in it, which we are subtracting. So all that understanding is semantics, and it is human semantics.
Absolutely.
The chimpanzee may not know that. So therefore, similarly, emotions is a much wider space.
It is.
NLP is a narrow space.
Yeah.
Sorry, I interject.
No, not at all, not at all. Yeah. Okay, so tags to emotions, but then tags to genres. Now you are asking about genres, right? So genres was a much simpler yet fuzzy concept. Many years ago, I think George Xanatakis was the first one to do genre classification. I still remember implementing his paper during my master's. It just came out a few years and then say, okay, we have to implement this. So then life was simpler. Now it's not, because you have I think because of globalization and just access to music from all over the world, you have such new genres coming up, all these sort of fusion, all mixed and matched. And then, so it's very interesting to see. Now, if I say Led Zeppelin is classic rock, hard rock, that's it. That's about it. It's rock music. But now you have so many where you have, I'll show you some examples, very fascinating. If I say pop music, you'll have now it will be pop, maybe a bit of rock, and then indie. Or you can have pop, BTS. Pop and BTS become a genre of sorts now, right? K-pop. So it's very interesting to see what you can do with this information. So you can extract genres from this as well, from the tags. And then there's a very interesting work done by Ferrer and Erola, where they try to, yes.
In our Indian context, if you have to understand as a student, what is the meaning of genres? Like,
Yes.
Like, what is the meaning of genre? For example.
Yeah, I gave a talk at NYU and I said, what is the Indian genre? Exactly that question. In my head, okay, love songs is one genre. Folk songs, one genre. Of course, you have classical music, that's it. And within classical, you can have Hindustani, you can have Carnatic, so on. Item songs is another genre. So what is the Indian genre? We don't know. And if Bhakti music, devotional music is, sorry?
Aren't these super genres and inside it's only the genres, maybe like rags?
I wouldn't, well, it's more, they've become more like topics, or in fact, I put all those into the variance arousal space, thinking, okay, if I were to do that, maybe classical music can go around the variance arousal space because it consists of so many emotions. There are theory, I mean, it's theory, there's theory there. But if I look at the hero entry song, that will be its own genre, and it will be one space in the valence arousal model. Item song will be just there, both male, female items there. Yeah, I don't know how appropriate that is, but anyway, the point is that Indian music, it's completely it's not explored at all, and that's the thing, right? There's so much we can do here, and with all of this background, nobody is doing it. PhDs, thesis, please. Okay, so okay, now I'm going back to my slides. Was there any other question? No? All right. So what they tried to do was to look at co-occurrences of these genres, and then to identify, okay, if rock and pop always come together, maybe they form a sort of a super genre. If metal, death metal and heavy metal always come together, then that's signifying something a bit larger. So based on this way of looking at co-occurrences in the tags, I have basically a matrix. I have all the songs, I have all possible genre labels, and then I have ones and zeros, or it can be weighted, doesn't matter. But then you can sort of decompose that matrix to identify patterns, right? Now, when you lose that, you might end up with, this is actually from last step in the data about, these are many, hundreds of thousands of songs. So you can notice that when I do that, this is a very interesting example. I just told you, teen pop, K-pop, Europe. So all of this is becoming, this seems to be driving. So if I want to know what teen pop is now, it seems to be K-pop. What was teen pop 10 years ago? Maybe it was different, right? So you must be wondering what K-pop is. Korean.
Hardstyle, you take know how guide you. Shouldn't hardstyle be there also?
Shouldn't is not the question. Maybe it should, but this is last FM data. If you do the same thing with music from data from India, maybe something else comes out. This is not Indian music here, classical or otherwise. And you have hip hop, punk, raps forming its own cluster. Even metal, you have two separate, you have Swedish death metal, doom metal, melodic metal, and Finnish Viking metal. That's different. So you realize that genres already is a fuzzy concept. But I think this is a very clever way of putting them together. Well, it's not mine, so I can say it's clever, I don't feel very, yeah. Please.
The other little more deep into what happens behind it. So we are in a vector space. So in that vector space, I'm sure you are there. I don't know who you are. To perform some latent variable analysis.
Yes.
So then you can't give the latent variable very important.
Yes.
So if you reduce the number of latent variables, you will get some meanings.
Sure.
increase the number of
More and more noise. Yeah. Yes.
So it's very important aspect of the
Mhm. Exactly.
Probably speaking how film music, classical music, at least one dimension of it, no.
Right.
So I think if we talk a little bit about like introduction of some amount of engineering footfall, that footfall is important.
So these were not all, this is just some examples, but again, when we do some decomposition of that matrix, you still, if we did agglomerative clustering to identify, well, first of all, how do you identify, again, like you said, the latent variables or how many clusters, right? So of course, there are different ways in agglomerative clustering where you can identify the cutoff, where it's a trade-off between within cluster distance to between cluster distance. Yeah. Yeah. Yeah.
So in this analysis, if we keep the right,
Mhm.
then it comes response to our semantics.
Agreed.
Otherwise not.
Otherwise not. So yeah, you're talking about.
Although they are addressing like that.
Yes. Definitely. I think it should be a good balance of using engineering techniques at the same time making sure it's interpretable enough. It makes sense. Otherwise, it doesn't matter, So, so this was, in fact, the genres that we got were plainly based on engineering techniques. There was no perceptual intervention, nothing there. But of course, this also reveals what is happening nowadays, right? So this way, but I think this interpretability is the biggest, that's what we want to know, at the end of the day, what it all means.
How many dialects are there of a language? In fact, to define what is Telugu, to define what is Kannada is a challenge.
Mhm.
So there are people in Gulbarga will say, this is more like Telugu than Kannada.
Right.
So dialects is another issue. I mean, written language is one thing, spoken language is one thing. Music is a huge version.
Yes.
A huge version. So I'm sure you can motivate.
Yeah. Can I have one? Please go ahead. Can I have another session? I cannot finish my slide. But yeah, please.
So I just wanted to know the demographics of Last FM. Like, is it in Scandinavia mostly, like
No.
because, like, for example, like from what I see here, like the distinction between like Finnish and Gothic metal versus melodic metal
Could only happen there.
Yeah, like I don't think, like personally, like just African American music, just all putting all funk soul with hip hop it's like it can show
Agreed.
some bias in the data set, like is what I'm trying.
Yeah, there was.
J-pop has funk elements. J-pop is basically funk, but Japanese funk.
Yeah, but then like if you look here, like it's putting it with like classical music, but like it's a little.
No, classical, it's Japanese classical. So again, it's I mean, it's not
No,
classical,
still, like,
but yeah,
It's
agreed.
fine,
Yes.
a fine difference. You would expect
Good
okay,
point.
Scandinavians to like.
Yeah, so basically all the tags that we're dealing with are user assigned tags. So which means people are free to tag. They have just, they have all the time in the world, they're listening to music and tagging it. I never did it. I don't know why, but people do that, right? So when they do that, this is what happens. And that's a very good point that it depends on who's tagging. That's the bias in your system. This is what comes out, right? Now, I don't know if we have any way of doing that sort of tagging here, then something else would come up, right? Yeah. Okay, with lyrics, what can we do? So now I have to rush, or I won't finish even if I rush, but okay, I'll see how far we get. So lyrics, we have, you can look at how repeatable the lyrics are, because you can look at compression. Again, these are all, techniques looking just derived from, plain old compression algorithms. So you can look at that. You can look at information content. Now, repetition information content might sound very similar, right? Because if it's quite repetitive, information content is low. But if there is a song like Daft Punk Around the World, around the world, it goes on, it keeps repeating, right? That's it. But then there could be other songs where there's just one word repeating. So one word repeating versus 10 words repeating, there would be a difference in information content, but repeatability, it would be high in repetition nevertheless. And then you also have readability or SMOG, as it's called. It's like a simple measure of gobbledygook. So basically it just, talks about how readable it is. If it's gibberish, it's low. If it is not, then it's much higher, right? So you can extract some basic information about lyrics, but you can also do topic modeling. Diction is one software that recently we've been using. And it has these limited approximately 40 concepts, right? And then let's say things like optimism, self-reference, hardship, exclusion, different sorts of themes. And then you can feed in the lyrics and it sort of gives you a measure of how much it exists in the lyrics. But that's just a limited set, right? But of course, you can use several of these language models now to extract emotions, to extract sentiments, themes, and so on, right? So you can do a lot with lyrics right now. And you can do all of this at a word level, sentence, paragraph, and so on, right? Okay. Now, one thing recently that we did was that, so when we use diction, it only gives so many concepts. But if I want to specifically understand how hopeless the lyrics are, then what am I supposed to do? Because that thing, let's say, does not exist in the model that I'm using. It's not even trained for that. What do I do? So what we then did was that we first identified text which signifies that particular theme, right? So in this case, we used what we call the Beck hopelessness scale. It is a standard diagnostic measure, also used in clinical settings sometimes. It has all these statements which sort of describe whether you're very hopeful or hopeless, right? So you have all these sentences, and then you have the lyrics, and then the same process where we project both of them using your language models into your, that's not how the latent semantic space looks, but it's just, for representation purposes. And then you look at the distance between those two. So when we did that, this is an example of a song, which these are the lyrics. God is up to something, get ready for your miracle and all. So when you read it, it seems hopeful, right? I mean, at least if you believe in God, if not, I don't know. But so this was, had a very high score on hopefulness, right? So that way, if we want to understand a particular theme from lyrics, then this is one way where we get text, which is actually signifying that, and then see how far or close it is from that. Okay. Now we have Llama model that we want to try. It's very new. I don't know. I just, it's, again, I'm hoping that that gives us some interesting insights as well. So let's see what that gives us, but that's still ongoing work. Now, not only that, you can also look at artist information, right? Because from all the songs, you get the artist information. So it also, you can now mine all this information from, let's say, Wikipedia. You can even get their political leanings. You can get the kinds of genres that, they predominantly compose in. You also get their date of birth. You get some idea about what kinds of artists are also that they're sort of consuming in terms of in terms of their music, right? And we in fact looked at it a little more when we started looking at tweets. People started sharing music during the Black Lives Matter movement. So we wanted to understand, okay, what kinds of artists are they sharing, right? Are they, the current artists, older artists? What about their origin and so on, right? So you can get a lot of information also this way. Okay, so now streaming platforms, I have just covered, not in brief, unfortunately, but now social media, what can you do? Well, social media, we know that is predominantly unstructured text, right? So what you can use the same NLP techniques for both. So I don't have to repeat that. So what you could do is, for example, you can summarize it and get topics, keywords, themes, sentiments, emotions, and so on, right? So this is the same techniques that you can use for social media text, at least from Reddit and Twitter. And again, you can do it at a word, sentence, paragraph, and document level as well. Okay, so just one example I'll give, and then I'll move on to the studies. So let's say this is one, this is from Reddit, where people are asking, need some relaxation music, or they're posting on that particular subreddit, they're querying for music. You can use these techniques and you can cluster all the sentences. For example, let's say that these two would sort of be projected closer in the semantic space, because both of them are asking for they want relaxation music that keeps them calm. And then, then the topic modeling might give us some words like relaxing and relief, right? So that way you can take, just hundreds and thousands of sentences and then cluster them, right? How you did for, this is something that we did in our recent paper. I'll get into the details in just a bit. And then from all of that information, you can come up with these topics, right? So what you can do with music tags, you can do with social tags. What you can do with lyrics, you can do with free text. So basically whatever I explained, same techniques apply here. Okay, so some studies. Okay, music consumption and emotional health, right? So this was the first, I gave you an example of unhealthy music listening strategies, depression and all of that. So these were studies that were in that direction. So the last FM study. So this is just 3 sentences on the background. So people with a tendency for depression demonstrate a liking for sad music. Higher musical engagement for emotion-focused coping is found, especially during periods of depression. So, and maladaptive music usage, which is the study I had explained before, is indicative of depression risk. All these are important because when you start exploring big data or just the work is exploratory, you need to have some background, you need to have some hypothesis, some theory. Otherwise, you will find something, but how do you make sense of it, right? How do you account for false positives? What do you do with all of that? So it's very important that when you're doing exploratory research, it's good to have something. Of course, we sometimes it's quite intuitive, it's implicit, because there's no reason why we randomly pick a data set and do things. Maybe some people do that, but there's some intuition as to why am I doing this with this data, right? So, but it's good to have some sort of theory behind it. So this is a theory behind all of that. And so the objectives with our study were, what are the kinds of online music consumption patterns associated with individuals at risk for depression, and how well can we predict them? Already we know from literature that they repeatedly listen to music, right? It doesn't make them feel good, but they seem to repeatedly listen to music. So if I can collect data of music listening histories of individuals who are at risk for depression, I should find that there's higher repetition in the music listening, right? At least that's one hypothesis. So the collection, in fact, this was presented in ISME in 2020. This was the first study that came out. So what we did was from 600 users, last FM users, we got this information: the Kessler psychological distress scale, healthy, unhealthy music scale, personality, and also their last FM username, right? So the way we got this also by posting, this was a survey that we posted on Last FM on Reddit, Facebook pages. So you have to find those communities and ask them to participate, right? That's how we got this data. Now, very important, when you get big data, how do you assess reliability? Of course, it depends on what kinds of data you're collecting and where from, but you have to assess something, right? So in the end, this was the demographics, predominantly male, but that's, we couldn't do much about it. So we have this Kessler's distress scale, humps, and neuroticism is part of the personality questionnaire. So first thing we do is calculate what we call the Cronbach alpha. It is a measure of internal consistency, right? It kind of, people can just randomly click, right? It's a questionnaire. They just do whatever they want and you can get noise. But this is a measure of how internally consistent your questionnaire and your data is. So I'm not getting into the details of that. Happy to explain later. These are standard measures we use when we have self-reported data, right? So all of them are above acceptable range. So which means that the data, there could be some noise, but it's still acceptable. But then another approach we also take is that we do a correlation between all of these, because we already know from previous literature that people who score high on distress scale also will score high on unhealthy scores. And they also score high on neuroticism. This is something that exists in music cognition research. So when you also find that on average, it's, all pairwise comparisons, it's 0.55 or more, that's actually quite a significant correlation. So that adds yet another layer of consistency to your data. All right. So now we've established that the data we can use, it's reliable enough so far. And then we take them, categorize them into at risk and no risk based on their distress levels. That is also given in literature. The next thing we do, we use we extract the last FM listening history. We do all this analysis that I explained, and then we do group comparisons. When you do group comparisons, how I also have to decide, do I look at 1 month, 2 months, 4 months, 1 year? How do I determine that? So we took We conducted the survey at point A, but by the time we started doing the analysis, it was already 5 months down the line because that's how much it takes. So we take plus minus 2 months, plus minus 3 months, and look at top 100 tracks, 200, 500, because we want to look at trends. It's important not just to take one particular threshold and say this is what we found. So we look at trends of all of these across all these timelines and tracks. Okay, I'm just summarizing the results. So in terms of usage statistics, individuals who are at risk, they were associated with increased number of sessions and total play count and repetitiveness index. And this is something that we would have hypothesized, right? And there is decreased exploration scores. Exploration scores, again, meaning that they don't explore too much. They don't go beyond what they usually listen to. They stick to that and they keep repeatedly listening to that. And then in terms of acoustic features, which were the Spotify features, we did not find any group differences, but it was about how the temporal variability in that, right? So that we found something there. So individuals who were at risk were associated with higher inertia in the emotion quadrant representing sadness. What that means is that they probably keep listening. Once they start listening to music, which is perceived as sad, they seem to continue listening to that, right? So simply put, that's what it means. And when it comes to tags, they are associated, such individuals are associated with consuming music that has these kinds of terms, right? So it's a lot more. So it's not that they don't consume music with other tags, just in comparison to the control group or no risk group. And very interestingly, the genres or super genres, right? What they were, what they gravitated more towards was the neo-pop, dream pop genres and less towards black metal. And in terms of lyrics, we find that they prefer songs with low valence and low arousal, right? Which is again representing this concept of sadness and also greater information content. So it's like this, which is, if you want to say, if you have ever noticed when music is very upbeat and happy, again, a lot of repetition, no one cares what the person is saying. But if you're sad, words say a lot. Words are extremely crucial. So it makes sense that the music that they listen to, there's a lot of information in the lyrics, right? So that also makes sense. Okay, yeah, in the interest of time, let's not go into these details. Okay, and we also looked at topics, and we find that at-risk individuals, they listen to music, the lyrics have, more of these themes, denial, self-reference, ambivalence, and all of that, and low in liberation familiarity. What that means, we can discuss later. We also were looking at specific themes. There is something called a chime framework of recovery, personal recovery and well-being. So we wanted to understand something more specific. So again, in interest of time, I won't get into that. But again, they listen to lyrics which are more hopeless, right? Now, why is all of this important, right? This is extremely crucial. One is, if we can identify all this, right, can we actually predict, that, okay, you are at risk for depression. You have to be aware of that. Most importantly, you need to be aware of what you're consuming and how you're consuming it, because it's not always about pushing music. We always think about recommendation systems. Maybe you don't want to recommend certain things. It's like an anti-recommender of sorts, right? But this anyway was not done in India. I mean, the participant pool was not from India. So currently we are working on an Indian population, and that's what we have, approximately 250. We are still working on it. And we have more information. I'm going to skip. It's ongoing work, so I do not want to talk about the results per se, but yeah. I'm going to skip that, but the main point I want to say is that all of this work, when we try to understand human behavior, it's great that we're trying to do more in India, but the associations also between just human, let's say, if I take the first point, which is about personal distress, which is related to empathic tendencies. So what we find is that in the West, people who get easily distressed by looking at someone in distress, it's been always associated with individuals who have a lot of stress in general. But in India, that's not even the case. So this has nothing to do with music at all. The way we function is completely different. So obviously, it's very important not only to do music research in India, but also to understand just human tendencies also in India, right? Can you imagine that if we see every person in distress, we get distressed in India, we can't function. It doesn't work like that, right? So before we even get into all of this, we really, really need to understand environmental and cultural factors also. And if I'm going to use personality questionnaires, if I'm going to use stress questionnaires, I need to make sure they're valid in India. Otherwise, it's not going to, count as much. So yeah, there's no way I can complete this talk because I had few more slides, but can I have 10 minutes? I don't know how all of you are. You must be sleepy, tired. No. Okay. Others so sleepy, tired can walk. You will sit and listen to me. Yeah. Okay. All right. Okay. I'll try to finish in 10 mints. Given that it started 15 minutes late, I'll take that liberty. Okay. So I'll be very fast here. So this is about online discourse study. So we looked at r/depression, 957,000 members, right? And we collected all their, we sort of filtered all the posts with the keyword music, right? From Jan 1st, 2010 to 2022. And then what we did, so a post looks something like this. You have titles, you have the description, you have people commenting on that and all of this, it just keeps going on and on. We sort of clustered all the titles. I showed you an example just now. And then we did some topic modeling to identify what is it that they talk about in terms of music in the context of depression, right? So just to show you the results, actually not this slide, maybe this slide. Yes. Yeah, okay, sure. All right, so when I take all those posts and cluster them, let me go to this slide. I think that would be easier. Yeah. Okay. So when I do topic modeling of titles, now it gives me all these clusters, right? It's important that you ensure that your approaches are correct, but that's not enough because there'll be lots of noise also in that. So what we do is we use techniques, NLP techniques to form these initial clusters, but we qualitatively assess them. This is very important because NLP has its own drawbacks. So what we do find broadly is that all of the posts, if I cluster them, I would have healthy strategies, unhealthy strategies, which we also found in that lab study. And then we also have certain aspects where people are talking about how they don't enjoy music at all. And if you want to design a recommendation system for someone suffering from depression, you should also understand that they don't even enjoy it. So who are you designing it for? What are you designing it for in the first place? And there's, of course, lots of music seeking behavior. So what, at least a takeaway from two things from this slide, you need to do qualitative assessment. When you're doing all this, you have to make sense of it. You have to sort of vet all of those things and to make sure that there's, as little noise as possible as well when you use these NLP tools. And also we find some new things, music as an addiction also. By the way, that's a new thing, music aversion, music addiction. That is something which is becoming very popular in music cognition. So that's, another area that's upcoming. And when we think about music that, so they say that this music makes me feel like shit, and they'll post something there. And that is what unhealthy listening strategies would be. And we find that such music is typically low in valence and is high in terms of self-reference, blame, and it's very low in optimism in terms of lyrics, right? So already this gives you an idea of this is the kind of music maybe you shouldn't be recommending for certain people, right? So this was one of the other results of the study. So then what do you do with all this information? Now we have the next step is that you could probably, again, first of all, you might want to understand what is it actually doing to your body. If I identify as a person who is high in terms of depression risk, and I'm listening to music in a maladaptive way, I need to know what it's doing to my body. So this is where you can do more control studies and move into wearable sensors and all of that, right? And then that's what you might want to design finally, saying stop listening to music like this. We're not saying that song is bad and we don't want to blame the artist for anything, absolutely not. But just saying that certain things don't consume in certain ways. Yeah, this Reddit is a great treasure trove to look at many things. We were looking at moving music, sorry about this, and autism and music, all of that. But I'm just going to end real quick with this.
Can you please talk about
There's no, can I talk about it after a few slides? We can talk about that, right? Just I want to finish what I thought I should be presenting. So I just want to quickly go through Twitter and music sharing in times of COVID and in time and during the Black Lives Matter movement. So this is where, so this is during COVID, where we expected all the tweets, we took wave 1 and wave 2, and we sort of tried to use filter things so that it's all what Indians shared. If we know that the Twitter user was from India, then we tried to just filter that to understand what's happening. So we compared what, COVID-19 first wave with just the same time previous year, and the second wave and same time previous year. But without getting into all these details, just the results real quick. So we also wanted to understand what they said. They said, this song, this music makes me feel this way, right? Again, all using NLP techniques. So what we did find was music was used when they posted about music, they say it was more about community. So it was more about community focused function rather than tending to a more self-serving utility. So they said this is, it's more about community. And acoustic features, music that they shared had lower valence and high energy during wave 1 of COVID. And of course, when we look at the lyrical themes, they shared a lot of music which had exclusion, actually satisfaction, hardship. So you have all these different themes. Now, what this exactly means, I mean, it's still partly exploratory, and I don't want to make too much out of this. I'm not a huge fan of Twitter, to be honest. I won't dig into what these results mean, but at least for this one, we found it very interesting for Black Lives Matter. So we took 6 months of when after hashtag BLM, surfaced, and then there was a lot of music sharing. And we took, control tweets, so just tweets which were not related, which did not have the hashtag BLM. And then we looked at songs, tweet text, and did all this analysis. And finally, what we found, of course, just so that you get the idea, there were several tweets and tracks with lyrics. So this is sort of the nature of the data. And what we found that within 6 months, more than 10,000 tweets along with music had been shared during Black Lives Matter movement. And then what was interesting is that the artists of the 1960s, and they were not African-American either, some of them. So you had some songs like Give Peace a Chance by the Beatles. You had Elvis Presley's, there was some other song which was also related to freedom and redemption. And so you had those, that's the kind of music that they were posting about. And then also we extracted these Spotify features, and we found that protest music that they shared, at least, it had high valence, danceability, instrumentalness and speechiness. So basically, if you want to move masses, it has to be, there should be something which helps you march accordingly. If you think about what it means to get people to move together, it should be danceable also, right? So this is the kind of nature of what was shared then. So if one wants to look at, let's say one wants to generate music, let's say, which is now AI is used for music generation, right? So why bother doing all of this at all? If I want to, if I want it to sound like protest music, maybe lyrically it should have certain themes, or maybe there's certain acoustic features that need to be tweaked so that it makes it more protest music-like. But that's me talking about it at a very surface level, because there is a lot of socio-cultural, political, background when we talk about protests. But acoustically, this is what we can at least think of what it could be. So lyrics also, they had less repetition, right? Because you are trying to convey a message. You're not going to say around the world. That's not the song that will be shared, several times. You will have something which has a lot of important things that you want to say. And the themes were more about aggression, hardship, cooperation and accomplishment. And then all of, this satisfaction, optimism obviously will be lower in protest music. Okay, I'm ending. So these are the studies. So what's a good thing about having all this big data and information? Well, now, like I said, you have fantastic opportunities to generate knowledge about the human musical experience and even create technologies that will allow you to investigate that. And anonymity makes, the best thing is that it's like a safety net of sorts, right? People can honestly share music and musical experiences. And that also, given that you have specific, especially Reddit has specific subreddits and channels, right? So you can actually narrow down and look at many individualized topics and understand the discourse around them. And importantly, it's more naturalistic than more constrained lab settings. Now, in terms of the good things, when you look at streaming platforms, you get psychological insights, not only about the mental states, right? You can think about their personality. There's so many other things that you can actually identify from that. It's not going to be easy, but definitely, if you take this approach that you are what you listen to, like you are what you wear, you are what you eat, you are what you listen to, you are how you listen to, and so forth. So that can give us a lot of cultural insights. But it's very important. It's also interesting to see the cultural and social influences, like this genre example that you gave. We know that, okay, if it's these particular countries, and this is what is happening, but here it might be something different. So trends, and this will help in market research recommendation, and finally hopes that there's something we can gather for personalized music therapy. Now, the bad and the ugly things. So the problem, yes, there's lots of noise, huge amounts of data, right? Lots of noise, language model errors, but one solution you can have is mixed methods, where you have quantitative, you have tools to quantify things, qualitatively assess them so that you know that what the tools are doing are actually perceptually relevant. And then you can have platform-specific biases, like I said, Twitter, social desirability, there's all of that, or it's just a narrow where it's just English-speaking population, right? So these are all some issues with that. But of course, you have to rephrase and situate questions accordingly for that. And access is always a problem. One day Twitter functions, the other day the API shuts. So this is, but what can you do about that? So to conclude, lab-based studies, they can help us, it's like this closed loop, right? Where what you have in the lab, you can go ahead, test it, and check what's happening on a large scale, then create new hypotheses. You might find something new, and then go test it again in the lab in a more controlled fashion. So I think this is a very good time to, be in that loop of sorts. So with that, I would like to thank everybody. These are all my students, colleagues. You can check more of the work there. And yeah, thank you so much for inviting me and listening and being patient. Thanks, Vipul, for organizing all of this. And yeah, thank you for your attention. You had a question. Request, okay. Oh, yes. I can show that slide if no one has questions. There's a question. Okay. I'll pull up the slide meanwhile.
Thank you for the wonderful talk.
Thank you.
I think big data gives us a good opportunity to scale things up. It's very
Yes.
nice. So my question is that in your study, you show the association between some listening strategy and the content they listen and the emotional condition or psychological condition. But whether these are causal relationships or not, seems like it's not very clear yet. Do you know, can you think of ways to design methods to find out the causal relationships or not? Because those are very valuable for music therapy.
Exactly. And that's why I would say that the wearable sensors and everyday, this experience sampling is, again, this is the new sort of trend in terms of cognition, right? Where you have your Fitbits, you have your watches, you have your mobile data sampling, all of this information. And it can capture what's happening, because if I know that this music is not helping you, then I would expect your body to react in certain ways. So I think one way to establish any causal relationship would be to do experience sampling, wearable sensors. That is a way to go. And then again, I guess one should. So what we also did was that after a year of collecting classroom data, we tried to get same people to give us their distress scores and all of that, saying that if they have become worse, of course, that is still correlational. What music they listen to, if they have become worse after that, we are not ascribing that condition to music alone. But I would say that that might give us some hints, but I think we do need to collect everyday activity for that. That's the only way to get any causal relationships, I would say.
Yeah, it's a complicated question, right? Like the wearable sensors, they can give you instant
Yes.
Physiological measurements.
Mm-hmm.
But whether the emotional effect is long-term or it's instant is not very clear.
That is true. Because again, you want to map emotions to physiological signals. There's no one-to-one mapping there. But I would imagine that usually what happens in experience sampling, it's just not the signals, but you have the app sometimes sends you these questions. How are you feeling now? What's happening? So without the subjective experiences, just signals don't mean much.
It's a combination.
It's a
of
combination.
the and
That is why mixed methods is the only way to go when humans are involved and then these experiences.
Thank you.
Thank you for the question.
Can we relate it if you want to judge, or if you want to identify how a human being is having some fear by doing speaking, or he's happy, or having some kind of surprise, like if any student got 9 point something CGPA, so he or she is very happy. So by speaking, that emotions is there.
Right, right.
So we are generally using prosodic features.
Yes, yes.
So can we relate?
Yeah, definitely. I think that emotion recognition from speech, I know that all that work is ongoing. So yeah, you can, again, the same experience sampling can ask your question and you can just speak your answer. Instead of saying I'm feeling happy, you type it in, you can just say it out. So it can prompt that. It's easier than actually typing it in on your phone. So I think that this is definitely one other modality we can use to identify states. Definitely, yeah. But again, it's not an easy thing because you are constantly tracking a person who wants to be tracked. People do want to be tracked, but there is also a lot of nowadays people are selling their data online. So I'm sure it's called unforgettable me. There's so many things there that so definitely doable, I'm sure. Yeah. I will pull up the autism slide till someone else. Okay. Right. So I'll just take a minute again. So autism and music. So one of my students was looking at r/autism, where people again are talking about music. Again, filter all of those posts and comments and sort of cluster all of them to understand what is the general discourse about. And what she did find is that people often talk about repetitive music listening because, of course, there is repetitive movements in certain individuals on the spectrum. It's common that they have that. So and also it's not that just because they move repetitively that they want to listen to it repetitively. But I think it's in one sense, it's sort of a mechanism which probably also helps them manage and focus. Because what happens is that they can be overstimulated because that's one of the at least latest theories that they believe in, that autistic individuals, they're hypersensitive to things and information. And so music sort of helps them in channelizing that and helping them focus. And that's why also repetitive music listening and certain kinds of music helps them with that focus. And of course, they generally ask people in that subreddit, what kinds of music can we listen to and all of that. And there is also this reluctance in sharing music. Sorry, this is not the title, my bad. We are still writing it up at this point. But interesting, the lyrical theme. So when we look at the kinds of music that they listen to, the themes are very similar to what anyone would listen to. Maybe these are the most common themes. But interestingly, there's some studies that say that nowadays lyrics are becoming more and more negative in general. And but that doesn't seem to be the kinds of music that they gravitate towards. And of course, all of this, we are putting it in the context of Baron Cohen's theory on, it's called the empathizing systemizing theory. And they talk about autistic individuals as high systemizers, meaning they focus on patterns and rules and not much on people and emotions, or it's not so they seem to like certain kinds of music. So there's this entire framework which tells you that such individuals might like very intense music, very complex music, which can be more classical music as well. And so we were also trying to check if that holds. We're still working on it, because what they find in lab settings and self-reports, whether that's exactly what they listen to in real life, right? So that's still going on. But this is in short, it's the same approach that we take of clustering and all of that. But musically, we are still looking into those aspects.
Yeah, just a follow-up to
Yeah.
this repetition, the idea of repetition. So, uh, are the songs themselves, like few songs like repeatedly listened to like in certain communities, and is that like weighted in these models in the sense that if one song is appearing multiple times,
Yeah.
are you like
We weight it. If it does occur multiple times, then that takes more precedence over the others.
okay? So
We weight
in that case, like is there like a biasing effect or like a clustering which happens within the data? Because if like when you're doing the reporting, you're reporting like the averaged out kind of statistics in the sense, right?
Yes.
So like, if you're like,
No, I do get what you mean. So one is that if I'm looking at repetition, we can look at it session wise, overall. And so again, if there's any, it's a simple thing. Depends on what statistic you're using to describe it. If I'm taking mean repetitiveness, am I taking median repetitiveness? So these,
no, like repetitiveness is one thing,
Hmm.
but like even at a larger context, like repetitive just brought this idea now.
Hmm.
Like for example, in the BLM
Yeah.
data set case, right? Like what I associate, the song I associate most with the thing is "We Gonna Be Alright" by
Hmm.
Kendrick Lamar.
Yeah.
And that has all the things which you listed negative. Like it has self-preference, it has optimism, like
But that's not
and
what
it's not a
it's
60s song. And
Yeah.
it's like everything which you told me about BLM.
It's
And
not,
why?
yeah.
Like one song for BLM, like so it's
I know. So again, it depends. So I don't quite remember if it was looking at retweets also. See, one is you just tweet, people retweeting. All it takes is one, and then that would be retweeted, and that's about it, right? So I don't remember that detail, but I'm sure we would have accounted for that and justified that. But yeah.
so it'll be interesting to see like where like We Gonna Be Alright like situates
Agreed.
itself in that space.
We did have African American artists as well in
Yeah.
music, but again, this was not in an Indian setting. This was just global, general. So I don't know if what was done here. I don't remember. Maybe it wasn't done here. It was.
Just a last question about that. Like, so was there like these were like Spotify links and stuff when it was
Yes.
shared? Okay.
Yes. Yes.
So it does not like also take into account like like videos which have music embedded in them. Like for example, people chanting "We Gonna Be Alright" during the protest.
No.
So,
No, it doesn't. It doesn't. So we only took the track information. So yeah, so that's the thing, right? Now you need to use multimedia, some sort of a multimedia approach to it. Yeah.
One of the challenges in the ASD is that, when typically ASD is onset, let's say around 2 to 3 years of the childhood.
Yeah.
It's very difficult. There is no DNA test to detect the ASD. So this is a vague question, a fuzzy question, right? Because I also don't know. So the community is struggling. Like, people have done some experiment in neuroscience where they heard the cries of infants which are suffering from autism versus the cries of infants which are controlled. So in the listener's brain, there is a specific region in the listener's brain which shows some changes when the cries are given as stimuli with respect to some region maybe in the brainstem like frontal gyrus where it is known to control the emotional content in the cry. So that experiment actually indicates that emotional content is highly compromised in the ASD individual. So my question was that in your earlier part of the talk, you were starting talking about the quantification of emotions and all. So, and then the ASD individuals are very perfectionists, like they want perfection. And maybe some of the people may not even want loud sounds around them. They want some kind of calm.
Yes.
So and they may not be reactive. So their social interaction skills are also very different, atypical. So this particular research, the one that was presented through this quantification, like sentiment, the other aspects of the lyrics and mostly emotional part of it. So any interrelationship like this musical cognition for the audience, spectrum disorder people with respect to the music listening also, and also the maybe even
Experience.
singing also, who knows, I think. And this is a vague question, I know, but I'm just trying to understand how much it can be, the vagueness can be reduced.
So is it about the vagueness of your question or? So, okay, yeah, so let me wrap my head around that. So you said
Sorry, I just.
that's fine, that's fine.
I have.
No, there is work. See, there's a lot of work on music therapy and autism, right? And that is where children engage in music making, which allows them to it helps them channel their behavior and improves their social communication when they start making music with somebody. This is at a slightly later level, not at the age of 2 or 3. But there is some work on you said brainstem response, right? So there is this group in NYU, Nina Kraus, her lab. They look at auditory brainstem, responses in the brainstem, particularly. This they do at a very young age for various things. So it's more like how well you can parse speech or syllables from noise.
So the response is for the listener or the response is for the ASD speaker?
Not speak. I'm not talking about speech at all. If you're talking about, you're speaking about young, toddlers and so on. So then it's not really about the speech. Cries, I don't know that. I don't know about that research. But definitely in terms of, there's some work where your fidelity, your brain's fidelity in terms of how, how well it can capture speech and noise superimposed. I think that is some indicative of several capabilities. In fact, they look at the brainstem. There was one study on autism. I don't know if it was for children or much older adults, but they know that brain's fidelity is an indicator of your reading capabilities, how soon you will have that, or you have language acquisition difficulties as a child. Autism, there was that study, but we'll have to figure out, but I don't, unfortunately, that's a bit away.
Trying to decode this few vagueness
through more vagueness put forth by there you go.
Thank you.
Thank you. Yeah.
Hello.
Hello.
Yeah,
there,
so
yes.
just in linking with this question, there are certain studies or researches going on here in India where they say that certain specific sutras or mantras are found to be helpful in kids' mental developmental stage. So are those like any studies used here, or are there any found in certain ways, like when we compare children who are exposed to certain sutras or mantras, and apart from the children, we are not exposed to those. So are there any certain level of mental development found, different type of mental development found in those children?
So this has nothing to do with autism, just
No.
healthy children. Yeah. So one is that I don't think there's as much research coming out on that, but yeah, I mean, that's really not my area. This is general cognition and some sort of intervention. But I would imagine that it would have an effect because there is certain, articulation required, repetitiveness, and memory processes. I mean, it's obvious that you might find something, right? But you can't say it is only because of that, or is it because of doing some other activities? If you don't have why only those and not, so you can look at Vedic chants versus something else. It could be, I don't know, nursery rhymes, or it could be something else. Anything that is similar in certain structural elements and the processes required for you to actually engage in them. So memory, language, articulation, all of that. So if you don't design that sort of a study and say, hey, we did this Vedic chants, it works. Yeah.
Can we say this is the last question?
Sure.
Yeah.
Last question.
Last question.
So also music is known to improve your mental state. So
Sorry, mental
state, like from a certain depression state to a certain happy state.
Not
only
always.
through,
yeah.
only through the music therapy. So are there any studies which discover or which study the progression from the depression state to the complete out of depression state?
So, well, first of all, I think that assumption you have to still question whether it always helps, because that was my point, that it may not always help. And that too, if you're in a severe state, then music, it's not going to help at all, right? But longitudinal studies,
It may not help, but it always adds a factor there.
of course, everything adds a factor.
So, are those any studies which help, which state the, which type of songs they used to listen and which were the graduate phases from moving out?
It's not, I don't think there are studies like that, because doing longitudinal work is extremely difficult, right? Because you need to follow them, track them for months together. It's not so easy to do. People just drop out of studies. So longitudinal research is difficult. NIMHANS might be doing some work on schizophrenia and music. That's what I know. Parkinson's and music helps them in certain ways. Depression is also difficult. It's a comorbid disorder at times. So you could have other disabilities and depression along with it. So answer is we don't have them yet, but I'm sure someone
Okay,
can
thank
do
you.
that. Okay, thank you for your attention.
Thank you, Professor Vinoo Alluri, ma'am, and engaging audience to have made the session a dynamic and informative one. I hope you all are enjoying the session so far. We are planning to capture a group photo to commemorate this wonderful event. We would be honored to have you all for a pic.